Next chapter will talk about two functional groups, carboxylic acid and nitrile, carbon triple bond nitrogen. Okay. So this again will review many reactions. So first let's talk about brief nomenclature. So these are this is carboxylic acid. So carboxylic acids are named from alkane. Okay. So you remove E and add oic or just in some cases ic acid. Okay. So what will happen? The product will be alkanoic or alkanic acid. So let's say see just one carbon. If you have one carbon hydrocarbon alkane, we say methane. So one carbon acid will be like this. Okay. So this will be called methanoic acid. Similarly, from ethane, if you have two carbons, that will be called ethanoic acid. Okay, and similarly, propane, propaneic acid, butane, butanoic acid, pentane, pentanoic acid, and so on. If two carboxylic acids are there, then it will be called dioic acid. So 3, tri, 4, tetra, and so on. Okay? But if it is cyclic structure and it has a carboxylic acid functional group, so in that case, it is just called carboxylic acid. Okay? Like this one, this will be called cyclohexane carboxylic acid. Okay. And if there are, so these carboxylic acids are considered as high priority functional group. If other functional groups are there, then those will be considered as derivatives. Like let's say this one here. Okay? So what this molecule will be called? 1, 2, 3, 4, 5. So at fourth carbon, it's a 4 hydroxy benzoic acid. Okay, so this is the 4 hydroxy benzoic acid. Similarly, if aromatic ring is there, okay, so they are called benzoic acid. Benzoic acid. Okay. And if other functional groups are there in this, then those functional groups are generally becomes derivative. So here it is, let's say NH2. Okay. So this molecule will be called 4-amino benzoic acid. Okay. Similarly, if you put like this one here, and let's say here you have that OH above the plane, and it goes below. In this case, you will have to say, you need to tell the stereochemistry, okay? So these both are trans in opposite. So this will be called trans 4-hydroxy cyclohexane carboxylic acid. Okay. So this is the brief nomenclature. So do the examples. So same. Do practice for this. And so nitrile functional group, similarly, carbon double bond nitrogen. So this is a nitrile functional group. Okay. So in this case, for alkane, you need to just add nitrile. Okay. So this is, and you don't remove the E. Remember here, you don't remove the E like unlike other functional group. So alkane nitrile. So like this molecule, see two carbon, you have two carbons. So two carbon hydrocarbons are ethane, but here you have that carbon triple bond nitrogen. So this molecule will be called ethane nitrile. Okay. Another nomenclature for this compound nitriles are popular. They are considered as acid derivatives. Okay, so in that case, like see this one here, CH3CO. What do we say this one? Ethanoic acid. Ethanoic acid. Okay. So, or general name of this molecule is acetic acid. See, these acids and nitriles are also acetic acid, same that is found in vinegar. Okay. So in this case, this one, we can name this one here. Just remove the E and ic acid and add O nitrile for this one. Okay, with the general name, what you do, ic acid is removed and O nitrile is added. So what will be this molecule will be called? Aceto, two carbons, see this one, acetonitrile. Okay. Similarly, if you have like this one here, oh sorry, nitrogen. So here you say benzoic acid. So remove eic acid and add nitrile. So this will be called benzonitrile. Okay. So in this But when it is, if then CN group is not a root, is not the molecule, root molecule, it becomes a derivative, low priority functional group, then it becomes cyano. What it becomes? Cyano. Like this molecule here, if nitrile and acid both are there on benzene here, Cn. Okay, this one. So this will be called, here is the nitrile, as it will be as a cyano, and it will come at the beginning of the nomenclature. So this will be 3-cyano benzoic acid. Okay. And similarly, I will give you guys one more example, last one. So let's say here, if you have OH, okay? This one. So here, you need to be careful, okay? Remember this point here. Generally, for numbering, we count all the carbons, okay? But here, this carbon belongs to the cyano as a functional group. Okay? So here it will be 1, 2, at 2, this functional group is present. So this will be called 2-cyano acetic acid. Okay, this carbon you don't count. You cannot say this one as 3-cyano propionic acid. No, it is not anymore propionic acid. This cyano C is a part of the functional group. Okay, any question? No. Okay, now let's come one very important, another in this important thing is the acidity. Acidity of carboxylic acids. Carboxylic acids like this one here, COOH, when you in a like this water, okay, solvent you dissolve, this happens acid base type reaction, it gets ionized, so it will be ROO minus H3O plus, so this is an acid that gives H plus. Water has here acts as a base, okay. You can take any like this one here, any other base like this pyridine. So what will be the reaction? This will react like this, and you will get RCOO minus, and it will be as a pyridinium carboxylate. Okay. Similarly, you can take any base, just like this one here, acetic acid, vinegar. Okay, in vinegar, if you add sodium bicarbonate, what will happen? Sodium bicarbonate base. See this one, try to understand, very simple reaction here. Sodium bicarbonate, this is the structure of sodium bicarbonate. Okay, so it has O minus. O minus is a base, the lone pairs of oxygen. This will take this proton, so it will make CH3, CO, O minus Na, plus it makes carbonic acid. And this one that decomposes to water and carbon dioxide. That's why if you add baking soda and vinegar, that effervescence or fizzing type thing will come out. That is because of the carbon dioxide gas release. Okay. Okay, so a few things you should remember here, that acidity. See, when we say this R group is attached, so it ionizes, okay, in a solvent like water, and it makes O minus as a conjugate base. Okay, so here it's a conjugate base. This one. So anything that, see, this is high electron density, anything that can pull the electrons away, neutralize these electrons, this negative charge, will make this conjugate base more stable. Okay, which means it is more stable, this H plus will be free. Okay, the reverse reaction will be less because this one is stable. So anything that can withdraw the electron cloud on the carboxylate ion will increase the acidity by increasing the concentration of free H plus. Okay, so electron withdrawing groups will increase the acidity, and in turn electron donating groups will decrease the acidity. Electron donating means more O minus means it will quickly grab the H plus and it will go backward. Okay, so this one, so now let's see this one here. If you have CH3, CH2, CH, and here you have Cl and COOH. Okay, and instead of, so here Cl is electron withdrawing, so this will withdraw the electron through the sigma bond, then this will go towards chlorine, that will make this one, the conjugate base O minus, more stable. So this is more acidic than this. Okay, CH2CO without the chlorine. Okay, so this electron withdrawing group closer to this carboxylic acid, it is more effective, means will make more acidic. So this will be less acidic than if this chlorine is little bit next carbon, one carbon away from the carboxylic acid. So this is a less acidic in the, just you can say, so this is less acidic here, this one than this. Okay, so most acidic one, then will be this one, then this will be the least acidic. Similarly, you can rank that one based on the nature of the substituent. Like fluorine has, like chlorine and bromine. Okay, so bromine has less electronegativity. So this, if you substitute with this bromine, then this will be more, sorry, less acidic than this one. Okay. Same thing is applicable for aromatic acids. And here again, you have to recall chapter 16. Okay. So at the para position, if electron withdrawing groups are present, like nitro, cyano, fluorine, Fluorine is electron nitrocyano, aldehyde, or ketone, or ester, or another carboxylic acid, that will increase the acidity because they are electron withdrawal. But if they are present at the meta position, okay, instead of para, if they are present in meta position, then that resonance will not be that much effective. See again chapter 16 and 17. So this will be less acidic than the para, okay, but it will be more acidic than the without the electron withdrawing group. Remember this one, okay. Now if suppose they are electron donating at para position, okay, like OH, okay, donating like OH or ethers, okay, like this OH attached or ethers attached or amine attached, they are donating. So what will do? They will decrease. So more donating, lesser the acidity. Okay. So let's say here the 4 molecules I have written the structure. So this will have the highest acidity. Then you will have this meta at meta position electron withdrawing. Then this will be without any, and this will be the least one in which electron donating groups are there. And again, you can further sub-ranking them based on the nature of the groups. Okay, any question? Okay, guys. So we will stop here. In the next class after the quiz, we will